Since there was already a video kind of describing the vertical compressions, shrinks, or stretches, expansions, etc., I'm just going to kind of go through these examples and just show the answers to them. So for this one, if you made the table, you should have gotten these points, and then if you graph the parabola, it looks like it's a little wider. And the same thing with this one, so when you graph this, that's even wider. And then for the second section, when you plotted these points, you should have got a more narrow parabola. And the same thing with here. So it's almost like you're taking these ends and you're pulling them upwards more and more. And when you get to the horizontal tables, when you substitute each number, you get 1, 0, and 1. And it looks like the parabola is getting kind of fatter. And the same thing here. So when I plot these points, it's getting even wider. So our goal is to try to take these examples and generalize them to statements. So the biggest confusing part, I think, is sometimes it's easy to get these mixed up. So like a vertical stretch might look like a horizontal shrink, or a horizontal stretch. So this graph right here kind of looks like one of these graphs up here. So they're kind of doing the same thing in that they're getting wider, but the words that we use to describe them are different based on the fact that one's vertical, one's horizontal, so they're different directions. And the second thing is the points would be a little bit different. So maybe the horizontal one would be just a little wider than the vertical one. So it gets a little confusing, and that is understandable. And then we have some horizontal shrinks. So if I use -1, 0, and 1, I get these points and I get a more narrow parabola. So it kind of looks like a vertical stretch. But again, because it's a little bit different than that, the points are a little bit different. So this might be just a little more stretched than a vertical stretch parabola. And the same thing here. So we're going to figure out a way to decide, how do you know if it's a horizontal stretch or a vertical stretch or horizontal shrink, etc. So these are going to be your two golden rules right here. So if you're taking the function and multiplying it by something, it's going to be a vertical stretch. If the number in front of x is greater than 1, it'll be a stretch. If it's between 0 and 1, it'll be a shrink. With the horizontal changes, you're going to be having something times x, but it's going to be on the inside of a grouping symbol. So inside, we need to think horizontal, and outside, we need to think vertical. And it's reversed. So if a is more than 1, so if the number in front of x is more than 1, it's going to be a shrink. And if it's between 0 and 1, it's going to be a stretch by a factor of 1 over a. So we'll kind of talk about that. So I've already written the answers for these examples so that you can go at your own pace. If you want to fast forward through the video, that's fine, whatever you need to do. I'm just going to go through each one here. Number 1, first thing I see is there is a 4 in front of x, but it's inside, so I'm thinking horizontal, right? And it's reverse order, so since the number is greater than 1, it's a shrink. So in terms of horizontally, it's going to get more narrow. So hopefully that part makes sense a little bit. If you draw a parabola and then you draw it a little bit wider or a little bit more narrow, this is getting vertically stretched, but left to right it's getting smaller, so they're opposite directions. If I draw a really wide parabola, left to right it's getting stretched out, but up and down it's getting closer and closer to the x-axis, so it's not as tall. So one's a shrink, one's a stretch. And the only way you can tell how to use the word horizontal or vertical is, where is the number? Is it inside or outside? That's the best way to tell. And then this part's it's going to be a little bit weird because it says by a factor of 1 over 4. So originally you're probably like, but the number in front of x is 4. But you have to think this is opposite of vertical. So basically what's happening is you start with this parabola, it's getting a little bit more narrow, more narrow. So it's shrinking each time left to right. So I want you to think it's going inwards 1/4 every time. That's kind of the way you need to think of the problem. All right, I'm going to hop over to number 6 because these are almost the same thing. All right, in fact, you will get the same graph here. Coincidentally, that doesn't always happen. So because 4 is in front, technically we would want to write vertical stretch by a factor of 4. Even though these are the same graph, we're trying to build a healthy habit here. So coefficient in front, vertical. Coefficient inside, horizontal. So for number 2, I see the coefficient is inside, so it's a horizontal. Since we have a number less than 1, it's a horizontal stretch. And you always take the opposite of this. So instead of by a factor of 1/3, we're going to flip-flop it and make it by a factor of 3. So it's going out 3 every time. And then it also has a horizontal shift to the right 1 unit. So how does that differentiate from here? Well, the 1/3 is outside this time, so it's a vertical. And since it's less than 1, it's a shrink. So these will be opposites. And you just keep the 1/3. Okay, so it is going down 1/3 every time. And it's going to move to the right 1 unit. So we have 1/2x. Okay. So we want to say is a horizontal stretch because the 2 technically is inside. But instead of saying by a factor of 2, since it's 2 in front of x, you want to say by a factor of 1/2. So it's kind of like you're taking the reciprocal of what's in front of x. And then for number 8, now it says 2 plus x. So you're not taking x times anything. So there is no stretching or shrinking. It is simply a horizontal shift to the left. Okay, so number 4, I know it's going to be a horizontal change because it's inside. So I'm going to say it's a horizontal. This would mean shrink since it's greater than 1 by a factor of the reciprocal 1/5. And that's it. Versus number 9, this time there's no parentheses. So 5 technically is outside the parentheses. So this time we're going to say it's a vertical stretch by a factor of 5. And then number 5, so I see several translations. All right, I see a 1/3 inside the symbol. So I'm going to say it's a horizontal stretch by a factor of, flip it, 3. It's also a shift to the left 1 and also a shift down 2. This time I'm going to put the 1/3 in front of the square root, which means it's going to be a vertical change. So it's going to be a vertical shrink because it's less than 1 by a factor of 1/3. And then it's going to be a horizontal shift left 1 unit and still the vertical shift down 2 units. So it's going to take some practice to get those horizontals and those verticals separated. The golden rule is, hey, if it's inside, you need to think horizontal. If it's outside, if you have the number outside, it's vertical. And you want to try to remember horizontals and verticals are opposite.